Good morning. Yes, good morning, Arif. Nicha, Atul. Yes, ma'am. Okay. Okay, then we can start. 35 students are here. Okay, last class, up to where did we do? Anyone remember? Saturday? Yeah, I think we have done till uh, till this types of filters, correct? Am I correct? Types of filters, Nanu said, yes. So types of filters up to here we have completed. Okay. So now you have known that for your filters there are two types, you can say, for on the basis of if it is asked on the basis of rate of filtration, then it is of two types, slow sand filter and your rapid sand filter. And again, rapid sand filter is again categorized into two, that is your rapid gravity filters and pressure filters. Okay. And basically, actually, people will ask about slow sand and rapid sand filter. Okay, these two are important. So today we will go to slow sand filters. So actually, in book, all these operational things and constructional details are given. So these things, no it's of no use to explain because these are all about the constructional details. Okay, so this diagram, if you can, you remember it. Okay, this diagram. Then after remembering the diagram, you can write 2-3 lines about each of the constituents. Okay, like enclosure, tank, filter, media, all those things. But constructional details is not much of importance. Okay, but you should know what things are present inside of a slow sand filter. Okay, so you need to remember some of the names, like what are the base materials, what are the filter media. Okay, all those things you need to remember. Then about your snow sand filter, yes. So in a brief, I'm going to tell you about your snow sand filter and your rapid sand filter. So what these two types of filters are. So snow sand filters and rapid gravity filters. From the name itself, I guess you can distinguish between the two. Okay, like slow and rapid. So one is, you can slow and rapid. From the name itself you can see that one will be some rate of filtration will be slow and the other rate of filtration will be fast. Yes, so slow sand filters, actually this has become obsolete for nowadays. Okay, it is not used, slow sand filters are not generally used nowadays, it has almost become obsolete. So slow sand filters, basically it has much drawbacks. Okay, it has much drawbacks than your rapid sand filters, since it was used until, when rapid gravity filters were not invented. Okay, till then these slow sand filters was used. Okay, but after seeing all these drawbacks and all, so the people, they thought to, construct one another filter, that his name is a rapid sand filter. Okay, so a rapid sand filter, it is far more better than your slow sand filter. But one thing, if one thing is that slow sand filter, okay, the filtered water, okay, the filtered water by which you get through slow sand filter is of much purer. Okay, the slow sand filter, it gives more purer water or more good result than your rapid sand filter. Okay, this line you remember. Okay, but generally if people say that slows and filters has drawbacks, so you might be thinking that slows and filters, this might not give much purer water than a rapid sand filter, but this is not like so. Rapid slow sand filter, it gives more purer water. Okay, more your result is more accurate than your rapid send filters. Okay, but then also one question arises, you might ask me that, ma'am, if slow send filter gives more accurate results, then why it is not used nowadays? Okay, why rapid send gravity filters are used? Clear? One question, it will arise in everybody's mind. Yes. So the reason is, you see, slow sand filters, although it gives you purer water than rapid gravity filters, but the one some drawbacks are there for slow sand filters. Okay, the drawbacks are like this, that slow sand filters, it requires a huge area. Okay, for the installation purposes, when you install a slow sand filter, you will be requiring a huge surface area, and obviously huge surface area means you will be needing a very huge amount of filter materials. Okay, filter materials like sand, gravels, all those things. Okay, if it requires a huge surface area, that means you will be requiring more filter materials. Okay, and that means what? Cost, it will increase. It is not economical because you need to buy more sand, more gravels, and all those things. Okay, so slows and filters, since it is requiring a huge surface area, but nowadays, but nowadays there are less areas. Okay, because nowadays cities are so much congested. Okay, so there is not much area that you can give to install a slow sand filter. Okay, so all those things are its drawbacks, that since it requires a huge surface area, so it is requiring a huge filter materials. So slows and filters, it is not appropriate for nowadays. But on the other hand, rapid gravity filters or rapid sand filters, you can say, those are they don't require a huge surface area. Okay, also their rate of filtration, okay, their rate of filtration is much greater than that of your slow sand filter. Okay, and slow sand filter, obviously it has a slow rate of filtration, so it can be used for large industries or large treatment plants. Okay, but nowadays also, as though it has become obsolete, but some treatment plants, very small treatment plants. Okay, very small treatment plants, they use slow sand filters. Okay, those who have space and all, but and they are very slow. I mean, they have very small treatment plant, so they can use slow sand filters nowadays also. But generally, if you see in a majority, the industries or the treatment plants, they use rapid sand gravity filters. Okay, so basically your rapid sand gravity filters, it has much advantages than your slow sand filter. Clear? So next, so from your slow sand filter, you can write little bit of lines. Actually, slows and filters, if some it is asks like what are the advantages of slows and filters, or disadvantages of slows and filters, what is the difference between slow sand and rapid sand filters, generally the difference comes. Okay, in exam purpose also, or if questions of 1 2 marks comes, then basically they will not ask you what is slow sand filter or what is rapid sand filters. They will ask you about the differences. Okay, or what is the major difference between slow sand and rapid sand filters, like that they can ask you. So basically constructional details, you can write it as your assignment, you can say. Okay, constructional details of slow sand filters and also rapid sand filters, you can write in your copy. You can draw this diagram. Okay, You can draw this diagram and you can write about the constructional details as your assignment work. Okay, you can write it. I will today. I will surely PDF. I will surely share with you. Today you can write. Okay. After the class only, I will share it to you in your WhatsApp group. So this is your slow set filter section view of a slow sand filter. Okay, so you write it down in your copy about the constructional details. Not much importance, but then also you should know. Then okay, so here you can see uses of slow sand filter. Okay, from here you see slow sand filters are best suited for smaller plants and for purifying waters with low colors, low turbidities, and low bacterial contents. Okay, so it is more suited for when the water is having low color, low turbidity, and low bacterial contents. Okay, however, because of their smaller rate of filtration, as I already said, their rate of filtration is very low. They require huge surface areas and large volumes of filtering materials, as I already explained. Okay, this makes them costly and uneconomical, especially for treating large scale supplies. They are therefore being replaced by rapid gravity filters at all the major cities and towns. They may, however, be preferred for smaller plants, for village supplies, or for individual industrial supplies, especially in hotter and underdeveloped countries like India. Okay, so you can write if it comes like what are the uses of slow sand filters, and then you can write all this. Okay, next let us solve one numerical problem for your sand filter, slow sand filter. This numerical, it is a design. Okay, design 6 slow sand filter beds from the following data. Okay, so you need to design 6 slow sand filters. Okay, so let us see. Your population to be served is given as your 50,000 persons. So that filter, it need to, the population it's served is your 50,000 persons. Then per capita demand. Okay, each person's demand is your 150 liters per head per day, or LPCD you can say. Rate of filtration, it is 180 liters per hour per meter square. The length of each bed is your twice the breadth. Okay, then assume maximum demand as 1.8 times the average daily demand. Also assume that one unit out of 6 will be kept as standby. Okay, it is one unit out of 6, one unit will be kept as standby, because if sometimes operational failures happen, then you can use that one unit as your you can it will serve your purpose. Okay, so first, as your population and also your per capita demand is given, population and per capita demand is given, so obviously you can find out the average daily demand. Okay, as we already got previously the formula for average daily demand, the formula is population into per capita demand. So you got here, if you multiply both, you will get 7.5 into 10 to the power 6 liters per day. Okay, then maximum daily demand, average, if you find average daily demand, then you can find maximum daily demand by multiplying 1.8 into your average daily demand. Okay, so you got your maximum daily demand as 13.5 into 10 to the power 6 liters per day. Okay, then rate of filtration per day, rate of filtration per day you need to find out. In the question it is given rate of filtration as 180 liters per hour per square meter. So it was mentioned in hour, but you need to convert it to day, since your average daily demand and maximum daily demand uh, you are getting the unit in day. So for that you need to convert the rate of filtration per day. from hour to day you need to convert. So you have to multiply it by 24, then it will become liters per square meter per day. Okay, then you can find out the total surface area. Okay, you can find out the surface area by dividing the maximum daily demand by rate of filtration per day. Maximum daily demand you already got as 13.5. Okay, then you need to divide it by your rate of filtration. Okay, then you will get the surface area here. Okay, so now in the question, it is given as that out of the 6 units, one of them it needs to be kept as standby. Okay, and so what will you do? Oh, you should design it for only 5 units. Okay, so you see the now we need to find out the area for each of the filter unit. So the total area, as you already found, as 3125, you need to divide it by 5, since we need to design now for only 5 units. Okay, then you will get the area for each of the filter unit. Okay, this was the total this was the total area. Okay, total area of the filter. But now if you need to design it for 5 filter units, you need to divide it by 5. Okay, so now you got for the area for each filter unit as your 625 square meter. Okay, now your one condition was again given that your length, okay, is equal to your 2 times of breadth. Okay, in the question it is given that length is equal to twice the breadth. So you put this condition. Okay, L is equal to twice B. Okay, you put this condition, then you will get the breadth as your 18 meter. Okay, so L you got here. See, if is L is equal to twice B. Okay, then area is what? Length into breadth. Okay, into your, yeah, sorry, is equal to your 625. Your area is given, correct? So now L it is given as twice B, so it is twice B. Again here B1, here B is there, so it will be your 2B square, correct? 2B square is equal to again 625. Okay, then you like that you calculate and you will get the breadth as your 18 meter. And again if you put in your length formula, you will get it to be the double, so it is 36 meter. Okay, so the answer is like hence use 6 filter units with 1 unit as standby, each unit of size 36 meter into 18 meter, arranged in series with 3 units on either side. Okay, so this is your, finally your answer is your length into breadth is your 18 by 36. Okay, the length and breadth of the filter. Okay, next is your again rapid filters, already explained. Okay, so also already told you to write the constructional details of slow sand and rapid gravity filters. Okay, so same things are provided here. Okay, so you just see in your this PDF I will provide you, so you see. Okay, so this drawing you need to draw. Okay, so for rapid gravity filters, you see here what are the uses of rapid gravity filters. So rapid gravity filters are the best and most economical, and therefore invariably used for treating public supplies, especially for large towns and cities. The treated waters are, however, not so much safe as those obtained from slow sand filters and need further treatment before they can be supplied to the general public. Okay. So one more reason is also there is that though rapid sand filters, it not gives you much purer water or much safer water than your slow sand filters, but you can use rapid gravity filters because of the advantages that it has from slow sand filter, and also that filtration is not the last step for your treatment process. Yes, you need to go for further treatments. So if somewhat impurity is also there in while after doing filtration by rapid gravity filters, then that water it will be sent to the next step. Yes, again that water will be treated, so it directly after filtration it is not going to be supplied to the public. So since more treatment processes are there and the water will be treated further, so you rapid gravity filter, the water that you get from rapid gravity filters, it is advantageable. Okay. So one more question. The previous one was for designing of your slows and filter, and this one is your designing of your rapid gravity filters. Okay, a very short numerical. Let us see. Uh, Design the approximate dimensions of a set of rapid gravity filters for treating water required for a population of 50,000, the rate of supply being 180 liters per day per person. The filters are rated to a work of 5,000 liters per hour per square meter. Assume whatever data are necessary and not given. So, first of all, it is in the solution you see. Assume that the given rate of supply is an average demand, and also assuming that the maximum daily demand is 1.8 times the average daily demand. Okay. So first we need to find out the maximum water demand. Actually, it is done directly. Okay, they are directly finding out the maximum daily demand in one formula itself. You see population. Okay, the population first. What we do? Population multiplied by we did the per capita demand. Yes. So here they are directly multiplying also with 1.8. They are not doing in two steps. They are just completing it in one step itself. So directly they are multiplying it by 1.8 into population into your per capita demand. Okay, so they are directly getting the maximum daily demand. Okay, that is your 16.2 million liters. Okay, so now the water demand per hour. Okay, they are finding the water demand per hour. So they are dividing the maximum water demand per day divided by 24. Okay, so they are dividing the answer by 24. So they are getting it to be 675 into 10 to the power 3 liters per hour. Okay, so the rate of filtration it is given as your 5,000 liters per hour per square meter. Okay, now you can find out the area similarly like you have found out in your slows and filters. So it is your water demand by your rate of filtration. So water demand you already got is 675 divided by rate of filtration is 5,000. So you get it to be 135 square meter. So here it is given that you need to design two units. Okay, since two units are required to be designed, so the area for each unit will what will it will be divided by 2. Okay, there in slows and filter it was given that 5 units you should design, so it was divided by 5, and now it is 2 units are required to design, so you need to divide it by 2 and you get the area for each filter as your 67.5 square meter. Okay, so now this one they have assumed. Okay, like for in designing a slow sand filter, this one you can assume as L is equal to 1.5B because it is given here. Assume whatever data are necessary or not given. So while studying the constructional details, I think you will get this one that you can assume if something is not given, the length you can assume as to be 1.5 is to B. Okay, sorry, 1.5 into B. So like that, they have put the uh, this L into B similarly. Okay, so they have got B to be 6.75. Okay, so it is written here, choose 6.75 meter width and 10 meter length. Hence, two units of size 10 meter and 6.75 meter are required. Okay, so this is the answer, 6.75 and 10 meter. Clear? So this is your whole answer. How to do the process for your designing. A very small designing sums. These two are. You will find it easy. Okay. Later you see while you do write in your copy and you see it later. Okay. Then it will be easy for you. Okay, next, quickly proceed to the slow sand filter and rapid gravity filters comparison. Okay, so there are many comparisons in this book. So there are almost 18 comparisons. So no need to write 18, and 18 will obviously not come in your this one exam. But sometimes they might ask you like compare slow sand filter and rapid gravity filter on the basis of suppose base material, okay, or suppose on the basis of sand, okay, like this they might give you the preferences, they might give you that the basis on this you compare. So that's why you need to study the whole comparison is necessary. Okay, so you see here number one, pre-treatment requirements. So it is given there, effluents either from plain sedimentation tanks or raw waters without any treatment are generally fed into them, and coagulation is not at all required. Okay, so here coagulation is not required, and the effluents that are directly not treated, okay, from plain sedimentation, only those are directly fed into the slow sand filters. But in rapid gravity filters, your coagulation, flocculation, and sedimentation is must. Okay, so that is the comparison depending on your pre-treatment requirements. Next is your base material. So what is the base material for slow sand filter? The gravel base supports the sand. It varies from 3 to 65 millimeter in size and 30 to 75 centimeter in depth. You need to remember the size. Okay, then for your rapid gravity filters, the gravel base supports the sand and also distributes the wash water uniformly on the surface of sand. Then you can directly remember the size. It varies from 3 to 40 in size, and its depth is slightly more, 60 to 90 centimeter. Okay, if you write the size of the gravel base, then it's okay. Okay, no need to write more sentences. And then the third one, it's about your filter media. So the effective size of filter media sand ranges between 0.2 and 0.4 and uniformity coefficient between 1.8 to 2.5 or 3. So here it is your effective size is 0.35 and 0.55, and your uniformity coefficient is 1.2 to 1.8. Okay, but here it is 1.8 to 2.5 or 3. Okay, so next is your like this, differences are given. Okay, many differences are given. You see, you do one thing here. It is already previously I have already given to students, so it is already marked by pen. You can see this 1 2 3, then this 5 6 9 15 16 17 18. So all these things you write down in your copy. Okay, these comparisons, those are marked in your by pen. You can write it down in your copy. Clear? So comparisons are easy, so I don't think I need to explain. Okay, one by one, I don't think I need to explain it. You can read it by yourself first. Okay, so with this your filtration purpose is finished. Okay, filtration treatment is finished. Now next is your disinfection is there, chlorination is there. So by next week, sorry, by this week, I will try to finish this treatment process. Okay, I will try to be as fast as I can because we are already in the first chapter. We have not gone to the second, third, fourth, fifth chapters are already left. But actually what you know, if your first and second chapter is completed, then third, fourth, fifth will not need time. Okay, so those chapters it can be completed in one class. Okay, so I have, I have thought it to be like that because first and second chapter is very, very, very huge because that was, a subject in your fifth and sixth semester, but now it's as a chapter. So I can't, ignore some points also because those are necessary and you need to know. So I'm going as fast as I can. So next, first and second chapter, if I complete, then the load will be less on me. Okay, so I will try. And third chapter is all about your pollution. You can read that chapter by yourself also, I guess. Okay. So first two chapters I will complete it nicely. Okay. So okay, 5 minutes are left. So let me take your attendance. Roll number 69. Roll number 51.
Present, ma'am. 51.
Okay, 52. 53. 54. 55. 56.
Ma'am, 54.
54. Okay. 55, 56, 57,
Yes,
50.
ma'am.
Roll number
57.
57.
57.
Okay.
Hello, ma'am. 53 present.
53.
53, ma'am.
Okay, okay. 53. Then 57 also present. 58, 59, 60, 61.
Present, ma'am.
Okay, 62, 63,
63.
63. Okay, 64, 65, 66.
Yes, ma'am. 66.
Okay, 67.
Present, ma'am.
Okay, 68, 69, 70.
Present, ma'am.
Ma'am,
68.
70.
Roll number
Ma'am, 68 present.
68 present. Okay.
Yes,
Ma'am,
ma'am.
70%.
70 present. Okay. 71.
Present.
Okay. 72.
Present, ma'am.
Okay. 73.
62 present, ma'am.
62 present. Okay.
Yes, ma'am. 62.
Okay. Then 73. Okay. 74.
24 present, ma'am.
74 present. Okay. 75.
Present, ma'am.
Present, ma'am. 75.
Okay. 76.
Present,
76
ma'am.
is an okay present. Then 77. 78.
Yes, ma'am. 78.
Okay. 79. 80.
Present,
81.
ma'am. 80.
80 present.
Ma'am,
Okay. 81.
Yes, ma'am.
82.
Present, ma'am. 82.
Okay, 83, 84, 85, 86, 85 present.
Yes,
What
ma'am.
number?
Present.
Okay,
Present, ma'am.
86, 87,
Yes, ma'am.
88. Roll number?
87.
87.
87.
Okay. 88.
yes, ma'am.
Okay. 89, 90.
Present, ma'am.
Okay. 91, 92,
Present, ma'am.
93,
Yes, ma'am.
94,
Present, ma'am.
95,
Yes, ma'am.
96, 97.
Present, ma'am. 97.
Okay. 98.
ma'am.
98 present. Okay. 99.
99.
Suraj Jamatia present. Okay. Present, right? Okay.
Yes, ma'am.
100.
Yes, ma'am.
Okay. 101.
Present, ma'am.
Okay. 102.
Present, ma'am.
103.
Present, ma'am.
Okay. 104. 105.
Yes, ma'am.
106.
Present, ma'am.
107.
Yes, ma'am.
108. 109.
Present, ma'am.
110.